Hi, I'm going to show you a simple video on Central Limit Theorem. Central Limit Theorem states that for a large sample size, the sampling distribution of the mean is approximately normal. The view on what a large sample size is varies, but it's generally accepted by statisticians that it's 30 to 40 samples. So in this short video I'm going to show you various orange coloured histograms of sample means and compare them to the blue coloured distribution of the population line. Please ignore any scales and detail of the graphs. This is limited by my poor ability to draw graphs. Let's start with an exponential distribution, which is not normally distributed. It's skewed to the left or to the right. In our example, the exponential distribution is right skew. You'll see that when we increase the sample size of the sample means, the shape of the distribution gradually becomes less right skew, and once the sample size is large enough, the sample becomes normally distributed. You'll then see that if you continue to increase the sample size, the distribution's tails get shorter and the data is much more concentrated around the mean. The second distribution we're going to look at is a geometric distribution. Again, in our example, the distribution is right skew. Like our first example, you'll see that when we increase the sample size of the sample means, the shape of the distribution gradually becomes less right skew. And once the sample size is large enough, the shape becomes normally distributed. The same principle applies as example 1. If you continue to increase the sample size, the distribution's tails get shorter and the data is more concentrated around the mean. Now how about a Poisson distribution? Once again our example's right skew. Like the first example, you'll see that as we increase the sample size of the sample means, the shape of the distribution gradually becomes right skew. And once the sample size is large enough, the sample becomes normally distributed. And again, you'll see if we continue to increase the sample size, the distribution's tails get shorter and the data is more concentrated around the mean. Finally, for a bit of variety, let's look at a uniform distribution. As you might expect, the uniform distribution is already normally distributed, even at small sample sizes. But of course, when you increase the sample size, the distribution tails get shorter and the data is more concentrated around the mean. So in summary, I apologise for the repetitive nature of this video, but showing the different examples does show that the Central Limit Theorem states that for large sample sizes, the sampling distribution of the mean is approximately normal when you look at various different sampling distributions. I hope you found this video helpful. Have a wonderful day.